Can everyone hear me? I am Carlisa Holden.
I'm Jasmine Johnson.
I'm Jonathan Stokes.
And today we're going to be presenting on the production of frozen pizza. So just a little introduction about pizza. Pizza is a flatbread that's generally topped with tomato sauce, cheese, and any other delicious toppings that you may choose. But for the sake of our presentation, we'll be focusing on cheese, frozen cheese pizza. And the term pizza was first recorded in the 20th century, but it was brought to the United States in the 19th century by Italian immigrants, specifically, I believe, from central Italy. And Americans spend a staggering $39.8 billion on fresh and frozen pizza, and as of 2014, in the year 2014, excuse me, Americans purchased more than $4.4 billion in frozen pizzas.
Okay, I will be giving the engineering portion of how our pizzas will be made. Other pizzas could be made differently. This is how we say that our pizza will be. We first start with raw ingredients, basically salt, sugar, yeast, cornmeal for flavor. Cornmeal for flavoring. I'm sorry, can you hear me? Okay. And water. The cheese and toppings will be also things coming into. But the actual process, the longest process that we have is actually the dough making process, which will be done on an industrial scale. The dough making process actually starts with combining the sugar, salt, yeast, cornmeal, and water together, and they'll mix for 4 minutes in as I'll show later, in a big mixer. The dough is then left to proof in a proof room, or it can left to be proof and rise there in the mixer. It depends on what they want to do. It's next sent to a chunking machine. The chunking machine actually breaks this big 200-300 pound chunk of dough into small portions so it can be sent through the other processes in the plant. The next part is it will go through a sheeting machine. I have pictures of all of these. The sheeting machine actually not breaks, but it comes from a large mound of dough and goes to sheets. Our actual size of our sheets for the crust would be 2 millimeters thick. No, not 2 millimeters. 2 centimeters thick. And then after that, it goes through a process called perforation. Perforation is basically small holes placed into the dough, which would be 7 to 10 millimeters thick. That is in the short baking process that we have, that is for air to escape through the dough. The next after that, flour brushes will get rid of any excess flour that was used for non-sticking, and then it will go into plastic cutters. I have pictures of that. Plastic cutters actually cuts the dough into the actual rounds. Now, think of it as it going through the machine. It goes into the rounds, and now you have perfect portions of dough. But the excess dough is actually taken off, remixed into another batch, so there's no waste. After that, it's baked for 2 minutes at 200 to 315 degrees Celsius in a conveyor oven. The next after that, it would be tomato sauce is added. This is a very interesting process because it shows how, for Dr. Kasama, it shows how the thickness of a product is used to control the flow onto the product. It is then pre-shredded toppings, such as ours is cheese, will be added to it during a waterfall applicator, and then after that it will go from some pieces will go to QA for testing. Those are later discarded, and then the rest will go to a glass cell for freezing for 20 minutes at negative 31.6 degrees Celsius, and then move on to an overwrapping machine and then a boxing machine. So that's our process flow chart. I have actual pictures of each one of these machines. This is the dough mixing. This is actually on the industrial scale, how big a dough mixer would look. You see someone actually put either water or whatever they're putting into the machine. This is the chunking machine. The chunking machine, the bigger area at the top opens up and you put a large amount of dough in, and it comes out in whatever portions that you want, 2, 3, 4, 1 pound portions. And that's how you start the process. Next, it goes on to the sheeting machine. The sheeting machine uses a myriad of rollers called quick reducers that gets the dough down to the desired thickness of your product, for your product. This is actually a home dough perforator, but I use this so you can see what it actually does. The home perforator, well, this would actually be a long pipe with this on it, and it would roll over the dough, creating holes. This is the cutter. This is how they would come out. That is the tool that will be inside the machine to actually cut. Actually, it's nothing but a bunch of circles over a cylinder, and it just rolls over and cuts out the dough. This is a conveyor oven. The conveyor oven is set to a certain temperature, and the speed is set to a certain speed. When I was looking through the website where this was at, it can be from 3 feet to 80 feet long. So you control the time, how fast it's moving, and come up with the desired temp or in the end of your product. This is the part I was talking about for Dr. Kasama. This is a reservoir sauce applicator. This actually uses, this is tomato sauce they're using right here. It's actually showing pieces being covered by tomato sauce. What happens is there's a reservoir of tomato sauce that this metal cylinder is in. It rotates, and there's a scraper. If you can see, this is the plastic scraper right here that the tomato sauce is scraped off of and comes down onto the product as a sheet. This is what I was saying, that the thickness, now if it's too thin and it's like water, it's not going to grab onto the cylinder that's rotating. If it's too thick, it's going to clump up. The perfect desired thickness of it is needed so that it comes down, flows on top, and you can control it coming down over the plastic scraper. It isn't wasteful. If you see a reservoir down here, anything that falls through the grates over there, it comes back and pumps back into the reservoir and used again. This is the waterfall applicator I was showing that, if you can see, that's cheese, and it goes from different conveyor belts, and the product will flow underneath it as it's pouring an even, steady stream of cheese over the top of it. This is a blast seal conveyor freezer. This works similar to the conveyor oven, except for now we're freezing. My biggest thing was how to keep the moving conveyor from freezing up at negative 31.6 degrees. But that's how it flows through all these different things, and then it'll come out as a frozen pizza. This would be the overwrapping machine. Overwrapping machine is nothing but 2 pieces of plastic, 1 piece of plastic underneath it, another piece of plastic over the top of it, and it's closing it up with like a heating system as a sealing system. This is the chemistry.
So in terms of the chemistry of our frozen pizza, first we want to take a look at how the dough is made. So the pizza dough consists of 4 basic ingredients, and that is, that is flour, salt, yeast, and warm water. And so what happens is that the dried yeast is full of the Saccharomyces cerevisiae, which are rehydrated by the warm water, and then they go to seek the sugar within the flour, and the products of that reaction is carbon dioxide and ethanol alcohol, which causes the rising of the dough. Something to definitely keep in mind here is time is a critical point in terms of the dough rising and the optimal fermentation of the glucose glucose by the yeast cells to carbon dioxide and the ethanol alcohol. Also, time allows for the formation or the development of gluten, which helps with the elasticity of the dough. So for the tomato paste, the optimal pH would be between 4.0 to 4.6. And of course, I guess what we would need to look at, we plan to get our paste from an outside source. So we would just be looking at lycopene content, of course, which causes the color, gives the red color of the tomatoes. And lycopene is a carotenoid and is useful in the absorption of light energy and protects from the photo damage of light. In terms of the chemistry of the cheese, retinin would be added, thermophilic bacteria would be added to the milk that would allow the bacteria to multiply and coagulate the milk. After coagulation, which also is termed as a cheese curd, that curd could be stretched into the formation and it would be allowed for quite some time to reach the pH of 5.2 to 5.5. And it would allow for, after that, for the mozzarella to be stretched into its form that makes it stringy for the pizza.
Okay, so for the food micro. So, can you hear me? Okay. So my partner just mentioned about the pH and the water activity. So Joe's water activity is 0.93 to 0.98. And so these are intrinsic factors. The ability for microorganisms to grow or to multiply in our food is determined by the food environment. So Joe provides the water activity of 0.93 and 0.98, the same as for tomato sauce and mozzarella. Now, gram-positive and gram-negative bacteria can grow in these environments. So some pathogens that affect pizza are Bacillus, E. coli, Salmonella typhimurium, Listeria, and Staphylococcus aureus. Now, Bacillus, E. coli, Salmonella, and Staphylococcus aureus, they are mesophilic. They grow in mesophilic temperatures. So that is room temperatures from your 20 degrees Celsius to your 35 degrees Celsius. Listeria, on the other hand, is a psychrotrophic bacteria, so it grows in those refrigerated temperatures such as 0 degrees Celsius to 4 degrees Celsius. So some critical control points for our bacteria would be obtaining the ingredients from a licensed and reputable sources. So making sure that before, like our ingredients that our suppliers ship us are within the limits for the bacteria. The storage at the room temperature. We also make sure that our pizza is baked at 200 to 315 degrees Celsius for 2 minutes, and that to eliminate the bacteria, we want to send it through the blast cell for 20 minutes at negative 31.6 degrees Celsius. And for our consumers, to be safe, we want to make sure that they serve their pizza at 58 degrees Celsius, which is the same as 135 degrees Fahrenheit, and make sure they do not leave their pizza out for more than 2 hours. So since the supplies are being received, or we're receiving supplies they could be contaminated prior to, so one way to eliminate our bacteria is to do the blast cell. And some pathogens can survive these low temperatures, such as Salmonella, E. coli, and Listeria. So some outbreaks that occurred, this occurred in 2007. It was Totino and Gino frozen pizza. It was an E. coli outbreak. 21 species were isolated. It's the 015787. 8 people were hospitalized. 4 people had developed kidney failure, but no reported deaths. And it was the pepperoni that was contaminated. And then recently, in 2015, March of 2015, Amy's Kitchen's organic pizza, the spinach pizza, was contaminated with Listeria monocytogenes, Listeria monocytogenes, I'm sorry. And they asked for volunteers to basically send back their products. Any questions? I'm trying to read that fast.